Good morning, good afternoon, and good evening, and welcome to Umlink Energy Speaks Back, powered by Hark. My name is Paul Webb. I'm the founder of B2B Energy, and I'm your host. And weekly, I present to you experts from around the world. Welcome to episode 83, and my special guests today are driving inspiration for power optimization in Australia and around the world. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. And on our journey of knowledge gathering and sharing, we would like to thank our sponsors, Carbon Black Global for their waste to energy initiatives, Cinefex for their insulation coating, Smart Cool for their AC initiatives, Umlink, who are taking the confusion out of energy management, Hark Systems, renowned for their energy software, Clean Energy Revolution for their knowledge and networking through LinkedIn, B2B Energy for their 11-week energy program and supporting organisations' management of their third largest expense after property and after people, led by Vision for their LED and controls, and Simewatts for the electronics and EV transition inspiration. And lastly, our certificate partners, Ester Energy. Our special guests today are experts in the power industry and are renowned for their works within the Australian sector. So without any further ado, I give you Dr. Bevan and his team from Elexsys. Good morning, good evening to my guests today in Australia. So how are you both Bevan and Stephen?
Excellent.
Well, we've got good weather.
You've always got good weather in Australia. That's the thing about Australia, isn't it?
Yeah, we have lots of sun, which helps us with our renewable energy, yeah.
Yes, and I wonder what we're going to be talking about today. So, Bevan, we've met once, and I've never met Stephen before. So, thank you for coming along today, and it's great to meet you both again. So, Bevan, I'm going to come to you first to give us some background into yourself regarding where you've come from, regarding your background and what you're doing today in the industry.
All right. A little bit of background. Bevan Holcomb. Electrical engineer for the last 30, 40 years. Basically working for the local distribution utility here in Brisbane for the last 30 odd years. Prior to that, I worked a little bit in the United States and things, but by and large, distribution utility work, senior engineer in that business. How did I get into this business? It all probably started around about 2005, 2006. Here in Brisbane, we started to see a fairly large increase in customer coming along and wanting to put rooftop solar on their things and connect to the network and generate back into that network. That was about 2005-6. It actually in Brisbane here, it probably started about the 2000 mark. But, there was only a few, like maybe 1,000, 2,000 customers a year. By about 2005-6, we started to see tens of thousands of people wanting to connect to the network with rooftop solar. The prices were coming down dramatically, and so people were starting to do that. Brisbane's got a very sunny climate, so well suited for rooftop solar here in Australia. About that time, I started to do some work for the utilities, for Energex to see what the effects of all that rooftop solar would be. About that time, we were predicting that we did some analysis on S-curves on the penetration of what we could see here in Brisbane with solar, rooftop solar, and we were forecasting around about 80% of the energy needs of southeast Queensland here could be supplied from rooftop solar. We were a bit surprised at that and said, look, if all things went to plan, then that's the amount of energy we could be actually supplying into our network from ordinary customers on our network. And what was the implications of that? So we started to look at the the upside was good. The downside was not so good. The downside was that we would start to see voltage rises on our networks. Here in Australia, we are governed by an Electricity Act, which says we have to maintain our voltages within what we call statutory limits. And back in those days, it was 240 volts plus or minus 6%. If we go too high, we usually shorten the life of white goods, customer equipment, these things, and maybe in the extreme, start a fire or have safety issues out there. If you're too low, again, some consequences with your equipment out there for that things there. So they overheat and maybe burn out or not start or burn out light bulbs and do these sorts of things out there. So we're required under Electricity Act to maintain those voltages. And when we did some analysis, we looked at what the penetration of rooftop solar would be, we started to see voltage rise on those low voltage networks, well in excess of what would be the statutory limits out there. So we set about trying to find a method of controlling that voltage on those networks so that we can at least put all the renewable energy that we could back into those networks. And we did a lot of things about upgrading transformers, upgrading conductors. All those things were very, very expensive to do. And the simple thing we came up with was what we call VAR management. This was a STATCOM. Basically, it's a piece of electronic device that acts as though it's an electronic conductor or capacitor. All right, so by about 2012, we completed a lot of the modelling work by about maybe 2010. By 2012, I retired and with my partner Richard, we set up the Elexsys business here in Australia. We couldn't find a product that would do what we wanted it to do. Basically a power electronic device that would be, capacitive, could go from capacitive to inductive type generation of VARs out on that network. So we set about building it ourselves. So by about 2013, we started to build the Elexsys product that we have today. Sort of like 2015, we completed that design. 2015, and since then we've been doing installs and trials and these sorts of things out there. It's been a slow uptake here in Australia. If you go into the theory of that rooftop solar or distributed generation out there, the network can handle a certain amount, what we call hosting capacity, which is the amount of solar generation compared to the rating of either the distribution transformer or the conductors on that field. And generally speaking, networks can handle around about maybe 30%, 20 to 30% before we start to see these voltage rise problems on certain customers. Here in Australia, and I'll give you a little anecdote. Richard would come to me. And this is probably no more than about 2 or 3 years ago. He says, "Bevan, we spent all this money and time developing the Elexsys product, but no one seems to need it." And then I said, "Just bide your time. Just be patient. The engineering is quite explicit about what is going to happen." And so here in Australia, when we went to talk to people, utilities, they'd say, "Look, we don't have a voltage problem out there." And that's because you needed a certain level, or you needed a minimum level before you'd see these problems. And about 2 years ago, well, at least 2 summers ago here in Australia, one of our sister states, South Australia, the whole state, we've had many, many days now in that state where the whole state has basically run off rooftop solar. And at that point in time, the utility came along and said, "Oh, yes, I think we have a problem now." They never thought they would get there. And a lot of our policy in Australia from our regulators and politicians here was all about large-scale solar and wind. But the distributed solar on rooftop actually caught up with them. And that was about 2019-20. And since then, there's been a flurry of activity here in Australia about how do we now manage the voltage. We're doing trials with government departments, federal departments saying, what do we do now? So there's 2 states here in Queensland and in South Australia where rooftop solar is generating about 30% here, maybe about 60 or 70% renewable in South Australia. So we're getting up there now where we're getting very close to our limits of maintaining stability on our networks. So everybody's worried about how do we now manage a network with large amounts of renewable energy going into it, both from a stability point of view and from a voltage and regulation point of view out there. So all things come to pass. All the work we did nearly 15 years ago now is just starting to happen. It's very predictable, all the stages of technology development we've got to do to make renewables, the main energy source for the world. So from our company point of view, we're still developing products that we need for renewable energy. Richard keeps saying, when are we going to stop all this R&D? And I said, not for a long time yet. I said,
it never ends. It never ends.
I've used is it took us 100 years to build the grids we have today. In fact, it's about 130 years since we started the first electricity grids in the world. Even if we did it in half that time, let's pretend we're twice as good as what we used to be at the turn of the 19th century, the 20th century. We've still got about 30 or 40 years of technology development to make renewable energy as reliable, more cost effective than what we've ever had in the past. We're still a long way from having all the technologies we require for a completely renewable energy grid out there.
So can I ask, the technology you're developing is around renewables, okay? So it stabilizes the voltage if you're using renewables. Does it have to be installed at site level, or does it go onto the grid?
It can be done either way. It really doesn't matter whether you do it in front of the meter or behind the meter out there, as long as you put it at the right place in the network. And the right place is, and this is where we have a lot of our IP and patents are around where you put where you select the right place on your network. Putting it at the transformer terminals or at the back end of the feeder is not the correct place. It's not the most efficient place to put our technologies out there. Now, as I said, Elexsys, we started off building hardware. If I look over the last 3 or 4 years, we're now doing a lot of software development because we're starting to go, well, hang on, I'll take you back one step. I have, and this is only my personal view, I have 4 eras of renewable energy development. The first era is over. This is where we've made wind and solar cost effective. We finished that. We started that sort of around about the 2000s, and we finished it probably in around about, say, 2020. Nice round number. That era is over now. I think it's very well understood around the world that solar generation and wind generation is the least cost form of energy generation out there. It's cheaper than coal. It's cheaper than oil. It's cheaper than nuclear. These sorts of things. Cheaper than hydrogen. So I think that era is over. The next era is battery technology. We've now got to bring the price of batteries down, and we've got to have a lot of batteries in our network. I was doing a presentation the other day for some American people, and I gave them some stats out of here in Australia. Australia uses about 200 terawatt hours of energy a year. All right. So that brings you back down to about 500 gigawatt hours a day on average. Around about, if you look at the load curves for the Australian electricity market, we use about, in our numbers, about half of that energy outside of solar hours. So we need about 250 gigawatt hours of batteries per day. Now, I know a lot of people talk about batteries in gigawatts. That's not the real measure you need. It's the energy storage capability of those batteries. We've got to be able to supply that energy over that period. And we've always talked about kilowatt hours and these sorts of things. So we need about 250 gigawatt hours for Australia. That's just to do the existing network, the existing electricity needs in Australia. Last 5 years, we've put in about 0.5 gigawatt hour of battery storage. At that rate, we would need nearly 500 years before we could say we were completely renewable. It's a huge task the world's got in front of it. We have to build factories to manufacture batteries. We've got to get them in the right places on the network. We've got all these sorts of things to do. So in my mind, we're in the beginning of the battery era. We need a lot of batteries out there to make us completely renewable out there. Otherwise, we'll be hung into doing, coal-fired power stations to take us through the nighttime hours and these things out there. So we're in the battery era at the moment. The next era after that is what I call microgrid eras. This is where we start to break networks up and run smaller utilities, smaller networks. And the reasons for that are around about network strengths. We'll need to do these sorts of things out there because that's the next big problem. We're just starting to see a bit of that in Australia now, whereas we go into the renewable world, our network strength decreases. Right? Now, network strength is a measure of the fault levels that you have out on your network, and voltage fluctuations and these sorts of things. So we've always relied on rotating machines to supply, huge fault currents when we have a fault on the network, or to supply the very short-term needs of loads coming on and off out there. When you go to the renewable world with inverter technologies, we can only ever supply load current. We can't supply the fault current that we're used to, like 10 or 20 times the current that we need, that we would normally see as a load current out there. So we've got challenges around how we would face that low strength networks out there. There's lots of academics looking at what the implications of that on our networks are today. We're doing the same on how we would build microgrids, how we use the Elexsys technology and these things to manage a low strength microgrid. We're building in facilities into our technology to say, I can find a fault out on that network, not by the amount of fault current that I see, but by the impedances of the networks out there. We're building that into our Elexsys products now. We will need that into the future. So we're into the microgrid era, and the last one, which I hazard to say, Paul, you and I will not see.
Thanks.
Everybody will have their own energy source. We'll be almost independent of a grid. Yeah. I'm sure hydrogen and probably some other technologies will come along, but that's probably your 50, 70, 80 years away out there. So we've got a lot of work to do from a technology point of view, from a policy point of view, to make all these sorts of things work for us.
But Bevan, you've just explained 4 eras there, areas. For me, they're all running in parallel, even though we're not actually seeing it. We're seeing batteries coming online, not many, but we are seeing them, and we are seeing microgrid being developed and being operated, especially in the States. So we are seeing these eras coming into fruition, but they haven't truly started. Is that what you're saying?
I think you're just seeing the beginning of the battery era, right? When I talk microgrids, a lot of people are using that word for a lot. It can mean a lot of things to different people out there. A lot of the microgrid technologies today is centered around still having a network connection or a rotating machine connection, so to supply that system strength. I'm talking about microgrids now, which are purely renewable and distributed. Very different exercise, and I don't know of hardly any out there today. They're all basically centralized big batteries or centralized solar farms with maybe a diesel or a network connection backup. So, it's a different world when we start to think about just totally renewable, which is where we need to go. And the world is trying to get there by 2050. So it's a huge task to get there by that time frame. And as I say, if you look here in Australia, and I look around the world, batteries are only just coming into play. Probably in the last maybe 3 or 4 years, we're starting to see those things. So it's very early days for batteries. And if I look at the way the batteries are being used out here, we're all here in Australia, nearly all the batteries are going into large scale transmission networks. And mainly for stability reasons, not for energy reasons, right? They're there to maintain the stability of the network. And that's why we've only put in a very limited amount of gigawatt hours in our batteries, because they're there for very short periods, only a few seconds or a few minutes to maintain the stability of those networks. Where I'm talking to in a battery era is where all of our non-solar hours or non-wind hours are supplied from batteries. It's a very different exercise than the way we're using batteries today. So the battery era has, well, dare I call it sub-eras, if you want to call it that, where we've got to transition from using batteries for short-term stability uses into pure energy supply uses coming down the track at us. And that's what we've got to do. That's just the nature of where we've got to go if we want to be complete running off renewables. Renewables are intermittent. They're not, they're at the behest of the weather, these sorts of things. So we've got to work around all that sort of stuff. So we've got to put enough batteries out there to make certain that we can at least have a network as reliable as what we've been used to in the last 20 to 50 years out there. And batteries are the newer technologies. How we use them, where we put them, they're all going in transmission networks at the moment, from what I've seen around the world. Very few are going into the distribution networks, and certainly into the low voltage. Here in Australia, our uptake in residential is fairly limited at this point in time. So we've got all of these sorts of things to do. So if you're putting them in every house, or I need them as a community battery on the low parts of the network, it doesn't help. Putting batteries at the high end of the network only helps certain stability issues and inertia issues and things like that. When you come to do energy and demand management, you need them on the low parts of the network. So we've got to evolve all these sorts of uses out there, and have markets encourage these sort of uses out there. So it's very early days yet. In my mind, the battery era has got to be at least 20 years. We just can't build factories quick enough to do these sorts of things. EVs are coming along. On my calculations here in Australia, if you take all of the energy requirements of Australia and put them over to renewables, we need our networks to probably carry at least 3 times the energy of what they're doing today. When we get rid of all of the transport, the EVs coming onto the network, we electrify everything, and industry comes over from coal and oil and these sorts of things and comes into electricity. Our networks have to supply, at least here in Australia, about 3 times, maybe as much as 4 times what we do today. That's a huge challenge for us. It's possible to do. We've done calculations that says, our networks can probably handle, the existing network can probably handle 3 times the throughput, but we need battery support to bring the peak demands down and level it out over the day and do all these sorts of things. So there's a huge amount of effort to go in technology and planning and design and policy creation to make all these sorts of things happen. It's very early days. One of my worst fears is that I don't think we're going to make 2050. If I look into the level of technology and policy change that we need, we're going to fall short of our 2050 targets. That's my personal view.
So Bevan, you described the issues you had in Australia. Are those issues replicated across the world? The technology is the same, but are the issues you think that we're going to be finding in Australia are going to be replicated, and your solutions and your ideas of how to fix those problems are going to be needed throughout the world?
Not everywhere, but the vast majority of the world, yes. If you look at where most people live, they live in the tropics, between the Tropic of Capricorn and Cancer and these sorts of things. Now, I don't think solar wind may be okay in some of the very northern and southerly countries in the world, like Siberia and Sweden and these sort of places. So solar might not be the answer for all those countries, but the vast majority of population, the solar will be probably the mainstay of renewable energy generation at this point in time. The costs are probably cheaper than wind at the moment, so I'm guessing that will filter through in the future years out there. So by and large, most of the world will probably be able to live off renewable out there. Yes, they'll all face the same problems we have here. We build grids, we do that. We may circumvent some of our technology we've been using for the last 50 years, like the one-way grid. If you're into developing world countries that don't have a very reliable electricity supply or these sorts of things, we may be able to circumvent that and go straight to the microgrid era, if you know what I mean. But by and large, regardless of where you are, Australia's in distributed things. Australia's one of the leaders. If you take Hawaii are even further advanced than we are. They've got huge voltage problems. In fact, the way the utilities get around the voltage problems at the moment, they just stop you from going onto the network. You cannot generate in. Hawaii has a policy now where you can't, even for small 5 kilowatt systems on your rooftop, you cannot export into the grid. You can put it on your house, but you can't export it. So, and that makes the economics not so good as compared to over here in Australia. Here in Australia, we've been doing, Elexsys has been doing, we started off doing large-scale commercial industrial, we call urban solar farms. Instead of putting large-scale things out in the middle of countries, we've been putting them right over the top of the customer's load, what we call urban solar farms. Probably about, for the last 5, 6, 7 years, about 80% of our customer installs that we've done have had either zero or limited export in Australia. So now Elexsys is going back in to help them actually put larger solar systems in and export that energy to other customers out there. So we've been trying to do that. Policymakers are coming along now and saying, yes, all right, we need to fix these voltage problems so that we can get that out there. An example would be, it's a true waste of energy when you can't export your excess solar generation in the middle of the day, right? From two reasons. One, from an economic point of view, and basically from a community point of view, because I've got all that solar radiation coming down and I can't use it in my house here, right? So I want to give it to other customers out there. There are about, here in Brisbane's a fairly diverse urban city, about 30% of our customer base, it used to be about 30% of our customer base, customers used to live in apartments or unit developments, these sorts of things. Places where they didn't have a large roof and they couldn't generate enough energy for their own needs. Here in my house, I'm generating probably on average about 20 to 25 kilowatt hours a day. I use something like about 10 or 12. A lot of my kids have left. So I've got excess energy here. I want to give it to other people. I have a roof. I need to supply it to those people who don't have that. So these are the sorts of things we want to be able to do with our...
Are you exporting that or transferring that to another area, or is it just been lost?
I'm exporting it, but again, we have limitations on how much you can export and do these sorts of things here in Australia. Yeah. Australia's done studies. We have enough. Well, I did it back probably 15 years ago. There's been a more recent study here in Australia where one of the universities here did a very detailed exercise, and they said Australia has enough rooftop area to supply all of the current electricity needs of the national electricity market here in Australia. In fact, it was more. It was about another 25% more. So we have all of that availability out there to do it. We just need to fix all the issues about getting that energy back onto the networks and give it to people
and manage it. Because the grid don't like it. The grid operators don't like it, do they? Because it's not guaranteed. They can't predict it, can they?
No, they can't. But we've learned to live that with that in the past anyway. Because even when you if you've ever been a power engineer, we use a thing called diversity, right? I'll give you an example of what we call diversity here in Australia. If I'm a single customer and I'm taking power off my network here, my household here, I could have an electric stove, an oven, which would be 5 or 6 kilowatts. Hot plates are about 2 kilowatts each. An air conditioner could be sort of like 10 kilowatts. You go and add all that up, and if I turned it all on at the same time, I would need probably 20 to 30 kilowatts, say 20 kilowatts as an individual customer, right? So I would need a transformer size to be capable of giving me that 20 kilowatts. When we design networks out there, like low voltage networks, we design them knowing that we've probably got 100 customers on that network. And these 100 customers use power differently. Everybody uses a power differently. We all turn a light on, not the same time. We all come home at different times. We have different families with kids that come home after school and do things, and then they go to bed early, and then Then we have the night owls like us who are here tonight doing these sorts of things. So when we design a network, back when I was at Energex there, we were allocating only 4 kilowatts per customer out there. So we designed a network with all that diversity in it. We can do the same thing with generation. Now, that was a load diversity. We need to evolve new things, and we're working on this now. If I had enough data, I could probably tell you what the diversity factors will be for generation, because even though we all generate, we're all using load at the different time over those generation things. And here at this side of Brisbane, it might be different to the other side over there, 20, 30 kilometres away. So we have to come up with new techniques to do that. I think it's possible to do, but again, that's the technology development we've got to go through to make all these things happen out there, to make renewable energy, ubiquitous out there, all encompassing to all the things, and as reliable or better reliability than what we've had with the one-way grid. So we have all that technology to go. So we're on our way. We're doing, Elexsys is doing share.
I was just about to come to Stephen, but he's just turned his camera off. You still there, Stephen?
I am.
So I'm going to come to Stephen now. I do apologise. You've been sitting, waiting there patiently, and we've been involved in a conversation around the technology that Elexsys had put together and Bevan's background. So, Stephen, thank you for joining us today, and I'd like to know more about your background and what your involvement is with the company.
Well, my position with Elexsys Energy is Director of Stakeholder Engagement, Strategy and Marketing. But before joining Elexsys now, 3.5 years ago, I had a long career in politics in Queensland. I was a member of Parliament for the State Parliament for 20 years. 13 of them as a minister, including 2 terms as energy minister. So a lot of what Bevan outlined in terms of the history, I was also involved with, and so for me, coming back and joining Elexsys Energy in many respects is completing a circle in terms of this, what I consider a fundamental issue of how do we transition to the somewhat hackneyed phrase now of a clean energy future. What are the practicalities of actually doing that? And please don't apologise for holding me up, because every time I listen to Bevan, I learn something new in terms of what it is that we need to do to put into effect that transition.
So I'm interested, Stephen. You've come from the politics side of our industry as such. So, are you gamekeeper turned poacher or poacher turned gamekeeper? Where do you sit between all of this?
Well, it is interesting because during the time that Bevan was talking about that first decade of the new century, there was quite a lot happening to the energy sector in Queensland, and it was a real hot-button political issue, because what we started to see, Queenslanders had enjoyed very cheap energy for many decades. Why? Because we had access to very cheap coal resources. The energy companies were owned by government, so government could artificially keep prices down, although ultimately we paid for that. When you stop investing what you need to do to keep your kit going, it's going to catch you out in the end, and it did in the first decade. But so during that first decade, what we started to see was electricity prices increasing significantly and it becoming a real political issue. So this was occurring at the time that Bevan was talking about renewables coming on the scene. And so we started to see incentives come into play, like very generous feed-in tariffs that were all about jump-starting the rooftop PV industry, particularly for the residential sector, as a means to provide relief or options for residential consumers to deal with those increasing electricity prices. We went from one of the lowest jurisdictions for electricity prices to one of the highest in the world within a decade. So it became a real issue. And so putting in place this very generous feed-in tariff for residential customers just turbocharged the race to put rooftop solar on residential premises. In fact, those very generous feed-in tariffs for those who took up the offer at the time will remain in place until 2028. So for those consumers who picked it up at the time, they're doing very nicely. Thank you very much.
Yeah. And is the country now being hit by the current global crisis that we're seeing, or are you just on the outskirts of that? Because obviously in the UK, we've seen some significant increases in our energy from 200%. In fact, I've seen 400% increases since lockdown last year.
No, we're not immune from from increases in world prices for oil and gas, even though we are now, I think, the world's largest exporter of gas. But those increases that you see coming through as a result of what's happening in Ukraine, Russia, etc., does flow back crazily somewhat to the price of gas that we pay here. So at the petrol pump, we're seeing prices that we've never seen before in Australia. Who knows how temporary they will be? But again, that just reignites the debate, particularly in terms of our very immature EV take up to date. We have, comparative to Europe, very small numbers of EVs. There are a whole range of reasons for that. But what we are seeing as a result of this, I won't call it a crisis, but the skyrocketing prices of both oil and gas, we're starting to see a debate emerging about the need to really take the transition to EVs far more seriously than we have today.
Do you miss your times in politics? Do you wish you could go back into that seat again and influence from that side? Are you happy where you are now?
I'm exceptionally happy where I am now. I still get to do. I still get to do interesting stuff in terms of policy. That's what Elexsys Energy allows me to do. Without the nonsense of, pardon me for saying this, having to deal with the media on a daily basis, or having to deal with Parliament. So intellectually, I'm just loving it. I can't thank Richard enough for reaching out to me those years ago to say, come on board.
I must admit, Stephen, that question was totally tongue-in-cheek, because I knew what the answer was going to be anyway, regarding not being in the hot seat anymore and just being able to have fun, but being in the hot seat now.
Yeah, you still get to do good things.
Yeah, exactly. And no one's going to moan about whether you make the right decision.
Well, Richard and Bevan still do, but that's okay.
Oh, yeah, but Richard would moan about anything. He's not here now, so he can't defend himself. But so, guys, it's come to this time where I'd like to ask you both, and I'm going to put you on the spot a little bit here, and I'm going to come to Bevan first. Is there anything that you can give back to our industry today regarding a takeaway from what you've experienced in your career, basically?
The background was always engineering, so we're moving ahead with the technology. But I said it's a huge challenge. There's a lot of things that we've got to still do. A lot of things we don't know about renewable energy out there today. So we've got to push ahead with our R&D. Elexsys, we spend probably nearly all of our profits on R&D at this point in time out there. So we've got a huge task to go ahead with R&D. But probably the biggest thing we need is good policy. And it's a mixture across Australia. Some states are doing better than others. Federal governments move around a bit. One of the disturbing things I see is that the engineering fraternity or the energy businesses seem to want to keep doing things the old way. You know, the way we've run a one-way grid for the last 50, 100 years, we seem to always be trying to build this new network, the two-way grid, in the same techniques that we're there, that we used to. So until we break that nexus, I don't think we're going to move ahead very fast. We've got to rethink. The engineers in the world have to rethink. We're building two-way grids. We've got to come up with new methods and new techniques to manage that grid. And a lot of our policy is still based around managing a one-way grid here in Australia. And I see that around the world. Some jurisdictions are a bit more progressive. You know, they've got policies which encourage renewable energies, these sorts of things, and batteries. But it's a bit of a mixture around the world when you come to see that. So here in Australia, I just don't see the policymakers moving quick enough and coming up with the right decisions in the right timeframes. So that's part of the course, and I think that's just the learning process that we've got to go through with this new era of two-way grids and renewable energy. I don't know how to make it any faster. I can't think of any ways.
We're in the same position in the UK. We have limitations on pushing stuff back onto the grid. And I understand why, but you talked about diversity earlier, and but there does need to be some form of control. I get that, but unfortunately, there's so much heavy legislation currently stopping it from happening. I've had quite a few projects that have been stopped because we were generating too much on site for the grid to, and we had to pay extortionate amount of money to upgrade the grid so we could put this on. So we had to wind back our systems to allow it to go forward. So there's all that going on. The grids, and I'm going to say this globally, need some investment in as well as upgrading, unfortunately.
Yeah, we do. We need to make it into a two-way grid. But again, we've got to do it. If we're trying to meet our 2050 targets, we've got to. The policymakers have to allow us to do it a lot quicker than what's happening out there today. And that's what I see here. We're very slow here in Australia. Policies that we put in 2 years ago, we've worked out 2 years later, they don't work anymore. And we can't afford to make that mistake and take that long to recognise that we've got things wrong. And even 2 years ago, we were saying things that, no, this won't work. And then it all comes true eventually. So somehow or other, and I don't know how to do that, the policymakers and the people making decisions, how the engineers, the engineering fraternity can agree on the best way forward to do this. And it's a real issue out here for us from an engineering point of view. There's that much diversity on views on how we tackle these problems. So that's life. We've got to move on with it. Yeah.
And then Stephen, I'm going to come to you now. Is there anything that you feel that?
Well, I'll just build on the riff that Bevan just engaged in, and to say that engineering professions, whether it be electrical, whatever discipline in engineering you follow, they tend to be very conservative, and there's very good reason, thankfully, why they are conservative by nature. But at some stage, you've got to also be courageous. And this is where it becomes, and I experienced this myself, this is where it becomes difficult for politicians. If the people who are advising you are saying, oh, Minister, if you go down that path, we can't guarantee that the lights will remain on, then every day of the week, that minister is going to say, well, I'm not going to go there. because that's your job. Your job is to keep the lights on, whilst at the same time finding the pathway to decarbonise, to reach those renewable energy targets. It ain't easy for all the reasons that Bevan has mentioned, but at some stage, if we are to avoid what Bevan mentioned about, in the foreseeable future, our electricity networks will have to manage 3 times the amount of energy being demanded by consumers. The old paradigm will be, well, that just results in billions of dollars of investment in new poles and wires, and you recoup that by higher prices by consumers. The new paradigm has to be, how do you use existing infrastructure smarter to cope with that increased demand, whilst at the same time ensuring that you don't put significantly more people into energy poverty, whether it be in Australia, the UK, or anywhere else in the world. That is the fundamental challenge, both political and engineering, if we are to transition to that clean energy future that we all want to see.
Well, I'd like to say to you both, thank you very much for joining us today on Energy Speaks Back, and hearing your wisdom and your words regarding your where you've come from, especially Bevan with the technology and delivering these solutions. I'm really excited about your technology, and I can see it actually evolving globally. I had a great pleasure of meeting with Richard over the last 6 months. It's been a really good journey with what you're doing with us regarding the sponsorship of this podcast as well. So I'd like to thank you for that, and thank you once again for joining us. And you now go and enjoy the rest of your evening, and I'm going to start my day in the UK. Thank you very much.
Thank you so much, Paul,
for having us.
And lastly, you and your families be safe in these times.
You too.
Thank you, Paul.